Okay, today's lesson, we're talking about properties of exponential functions, and our goal today is to be able to go through an investigation and determine the general properties. So I didn't bother listing the goal because the goal is on the investigation package. So I want to refresh your memory as to what the exponential function looks like. So talking about the general equation itself. General equation is usually in this notation: f of x equals a b to the exponent x. So again, we have name of function, independent variable. Our a value is our coefficient. Our b value is the base, very important. And then there's our independent variable in the equation itself. So all the exponentials that we're going to deal with this semester, the function or the general equation is f of x equals a b to the exponent x. And again, just as a reminder, that exponent b or x only applies to the base here. All right, so the b and the x are the same. It's really then being multiplied by the a value afterwards. Some terminology in order to be able to go through and do the investigation successfully. X-intercept, we're looking at the point where a graph crosses the x-axis. Similarly, the y-intercept, the point where a graph crosses the y-axis. Okay. Talking about increasing and decreasing functions. Increasing and decreasing. We're looking at the end traits, the end properties here, so it's the same direction you read a book. So for example, if you're looking at a function that looks something like that, this is the direction that you would read. And in this case, our y values are increasing. So in the direction we read the book, it's going upward. And inversely, if I had a function that looked like that, again, we're reading it the same way you'd read a book. So as you move your eyes from left to right, the y values are decreasing. Okay. So we're looking at whether the y values are increasing or whether the y values are decreasing. Now, the one thing I do want to add in here that's not in the note, so we're going to add in a term here. It's the word asymptote. Very important with an exponential. The definition, an asymptote is a line that a graph approaches but never touches or crosses. Approaches but never touches or crosses. All right, and an example, usually we show an asymptote with a dashed line on a graph. So I put my dashed line there. We can see down here where the graph is getting close to my dashed line but never crosses. Okay. Asymptotes can go in the opposite direction as well. They can be vertical. We'll call them vertical asymptotes. So could look like this. And it's approaching it but never ever ever crosses. So it's getting really, really close to it, but never crosses. So that's what an asymptote is. And so there's some of the key concepts you need to know when you talk about the properties of an exponential function. So in this investigation, okay, with this function, this is what I want you to focus on or look at. Okay, so first thing is the effect the a value, or the coefficient, has on the graph or function. Secondly, I want to know the effect the b value has on the graph or function. And finally, I want to know the effect of x, the independent variable, on the graph or function. So the investigation is going to lead you through, and it's going to look at each component individually. Okay, you're going to have to make some observations using the graphing calculator. So you're not doing hundreds and hundreds of graphs here. Okay, you're going to use the graphing calculator, and you're going to give me a sketch so I know you did it properly. And then, so these are the three things I want you to come out with. So if you want to think of it as, here are your goals. Okay. And what I'm going to do is I'm going to have you go through and do the investigation. So just ask me for class for the investigation. You're going to work through it. You're going to submit it, and it's going to go toward your thinking category in this particular unit.